Hi everyone, welcome back to our channel. In our today's video, we are going to discuss about asymptotic notations. In our previous video, we have discussed about the efficiency of an algorithm, how we calculate efficiency of an algorithm. So if you remember that efficiency of algorithm can be measured in two parts, one in time complexity and other in terms of space complexity, right? Also, if you have remembered there, when we have discussed about what is time complexity and how we calculate both of them, we have given some of of the algorithm as something like this expression. If you remember, O of log n, right? O of n cube, O of 1, something like this we have given, right? So today we are going to discuss about this. What is this big O, right? Right? So that is what our today's video dedicated to. These are called as asymptotic notations, right? So what is asymptotic notations? If you want to generalize it, asymptotic notations are used to compare and rank the order of growth of a function. Now if you remember some of the algorithms, like we have seen so many examples of time complexity and space complexity. Let's say in general, let's say selection sort. So there we have O of n square in best case, right? So this n square is nothing but this function. So for example, in future, if you have two algorithm 1 and algorithm 2, now you have to compare the growth of those algorithm time complexity. Or for example, this algorithm have O of n square and this have n log n, right? So in our previous video, we have also discussed about what is called as efficiency of class. So when we have the same notation, it is easier. We can discuss and derive by the efficiency of class, but somewhere you will see something like n cube, omega of n cube, right? So what is this, right? What is this? What is big O, right? So these are nothing but called as asymptotic notations. What we mean by these big O, big omega, small omega, we will discuss in our next video in detail. So to understand the basic here, you have to remember that asymptotic notations are used to compare the rank and order of the growth. So if you have function 1 and you have function 2, so how you can compare function 1 with function 2? Which one is function 1 is greater than equal to function 2, or function 1 is less than or equal to function 2? Function 1 is equal to function 2. How you can compare those functions, right, with the help of asymptotic notations, right? Let's go ahead. There are 5 types of different notations, 5 different notations. So these are standard notations. So if you're not understanding, be with the videos. In coming videos, you will understand that what I exactly mean when I say is to compare the videos, to compare the growth, right? So there are 5 different notations, standard notations. So in any algorithm, you may see any of them being used. So there are 5 different standard notations: 1, 2, 3, 4 and 5. First one is big O, which we were using, right? Then second one is big omega, which is represented by this way. Then we have theta, which is represented this way. Then we have small o, which we represent by small o, and we have something called as small omega. So any function of a time complexity will either be represented in any of these 5 notations. Either it is big omega, theta, small omega, right? Will be in any of these 5. Correct? Now, in our next video, we also be understanding what is big omega separately, what is big theta, what is small omega. All this, right, we'll be discussing in detail in our next videos. Also, I'll give a one comparison, general comparison to this, what this explicitly means. So you will see that big omega is nothing but less than equal to, greater than equal to, theta is equal to, less than or greater than. Don't about worry about these symbols. We'll see in our next videos about this. But to understand the basic, you have to understand that asymptotic notations are nothing but these are kind of standard symbolized symbols which are needed to compare the functions of an algorithm in terms of time complexity. So this is what we mean by asymptotic notations. If you understood it and you like the videos, please like, share and subscribe. Also be with the videos for our next coming series. You will understand